Okay, welcome to this presentation. Um, we're going to talk about the strategy design pattern, and this is being presented by James Alves and Logan Keith. Um, a small overview about the strategy design pattern. Um, this is a strategy where we can reuse lots of algorithms depending on the situation. I'm going to start with a very simple example, a very simple and general example, and then we're going to go into a more detailed one. So for this example, I'm going to use Harry Potter. Maybe some people are not familiar with Harry Potter, but the example might still work. So let's say that in our software we have a wizard that casts a spell. And depending on the wizard, this wizard might have a default spell, which is like the spell that this wizard is always gonna use. So for our program, if we change the wizard, we're gonna have a different algorithm for the different spell, and that's the beauty of the strategy design. So for example, in here, we have two options here. We have the Expelliarmus and Avada Kedavra, and in this case, if we are using Harry, Harry might use Expelliarmus. But if it's Voldemort, he would use Avada Kedavra. So that's the cool thing about this strategy design. So if we change the context, in this case we change the wizard, the algorithm that is suited for it will be used. So we change the context, and we are going to use the correct strategy for it. So that's a simple example on how to use the strategy design pattern.
Okay, so let's say you had a program where you want to represent different birds. You have seagulls, pigeons, penguins, and ostriches. So bird has a display method and a fly method. Each different bird will override the display method because they all look different, but penguin and ostrich will be the only ones that override the fly method because they're the only two there that don't fly. Otherwise, seagull and pigeon, since they do fly, they'll just use the default fly method. Okay, and then a better way to segment this out would be using some more inheritance. You could extend bird and make a flying bird that has the fly method, and then seagull and pigeon can extend flying bird, and then penguin and ostrich won't because they don't fly. And then following the same approach, if we wanted to make a swimming bird, because seagull and penguins can both swim, but ostriches and pigeons can't, we can follow the same approach. Swimming bird extends bird, seagull and penguin both extend swimming bird. The issue with this is, first off, this is a case of multiple inheritance where seagull is inheriting from flying bird as well as swimming bird. There's a lot of problems with that by itself that we won't get into here. A lot of programming languages don't support it either. But mainly, the more inheritance we have, the messier our code's going to end up being. So the better way to do this is follow the strategy pattern. So bird will have a fly and a swim method, and then bird will have member variables of fly type and swim type. And then if we create an interface for each strategy, for example, we have the flying strategy that has a function fly, and then we have a flying type and a non-flying type that both implement that interface with their respective fly methods. So then this is great because we don't have like a messy tree structure with inheritance. And then, for example, with our penguin, inside of its constructor, we would set our fly equal to a new instance of non-flying type.
Great. So now we're gonna have an example for our plant identifying app, and This fits really well. This most of this code was came from an example on the internet that is cited in our sources. And since this is going to be a mobile app, the Java programming language is a good one because people use Java to make Android apps. Where we're going to focus on how the strategy design applies to our app if we would implement it in there. In this case, we're talking about the action of selecting an image of the plant that we want to upload to define what type of plant it is. So in this case, our strategy is going to define what context we are. So the context, we have three options for the context. We can either take a picture right there and then. We can or upload a picture that we already have in our files. And the third one that was not in our SRS, but it could be included, is a screenshot, for example. And the concrete strategy would be the algorithm. So if it, sorry, it would be the algorithm. So for example, for the get plant picture, we have the same thing. In this case, we're opening the camera, or maybe we're opening the file structure or anything. So if you're looking at strategy, we're always using execute strategy. Execute strategy. So the strategy is the same, but if the context changes, we're going to use the appropriate algorithm for it. So let's go for a little demo. I'm going to show this working. It's running right now. It's on Java. So you have the questions here at the end. So how do you want to discover the species of your plant? And we have three options. Take a picture, upload the existing picture, or take a screenshot. So in the app, that doesn't really matter how it's going to be displayed. Let's say the user wants to take a picture. In this case, it's one. And you can see here opening the camera to take the image of the plant. Or let's say the user has a file that they want to use. They'll click to get a file, and it's going to launch the file selector. So on the outside, it doesn't make any difference. We can display however we want. But on the inside, we're always following the same path. We're always executing the same function in this case, which is execute strategy. And then the algorithm that we're going to use will depend on the context. So this is a way that we could apply strategy design to our app. So it is very flexible, as we saw in our examples. Depending on what's happening or what the user wants to do, we can change, making the app very autonomous, making we can leave it to the situation and the app is going to adapt accordingly. We don't have to create an algorithm that addresses all the issues. We can encapsulate all the algorithms by themselves, which make the algorithms very reusable. And a downside is that it's not very suitable for static apps, or let's say your app does only one thing, or you're fine having one algorithm for your function calls, then it's not worth the hassle of implementing the strategy design pattern.
And then another downside we have, and this one shouldn't be a huge issue most of the time, but overall you end up having more objects in memory because each strategy is represented as its own object.
Right, and then the recommendations for a plant identifying app, the strategy design pattern is awesome for mobile applications. So here's an example. If your phone, for example, has a very bad internet connection, we might have a different algorithm to address the situation. Or if the app is going slow because there's not much memory, the app is struggling to work, we could have different algorithms to address these situations, but we're still following the same path. We're still trying to do an action, and we're, depending on the situation, we're gonna pick the best algorithm. So using the actual terms for the strategy design, if the context changes, and the context can be the user trying to do something different, or maybe the situation as in low memory or bad internet, we're going to pick the best algorithm for it. So that's a great way to implement strategy design in our app.
Okay, and then another good place to use the strategy design is like in the example I went over earlier. Anytime you have really complex inheritance and there's a bunch of child classes that are replicating code, this would be a really good use case for the strategy design pattern.
Awesome. So those are our sources, and thank you for watching this presentation.